Okay. Yeah, then let's get started. So today and then actually we need to form the project teams. So I think it's somewhat important. So before that, and then I just want to provide some simple kind of lecture, and then after that, Jiyoung can help you, and the Jiyoung and Krishna gonna help you about the program itself. So right now, and then we are using something called YOLO. And then, well, not just, learning YOLO and then create, any kind of model. So what we want to do is, how actually we can create some better model. So I want to introduce some brief, kind of description about, yeah, how actually we are developing the model, and then there's something called, the fine tuning, how actually we can, play with, the model, and then we can enhance some kind of accuracy. So and then here is some materials, and by the way I shared this slide so you can find it. Okay, can you see my slide? Okay, good. All right, so this is titled like understanding basic models in image machine learning. So basically, what is the base model? And then we need to understand this. So sometimes it is called backbone model or pre-trained model. So this is a kind of deep learning model. To train a model, especially in image machine learning. So, well, there are some kind of common things. So, for example, yeah, detecting cat, detecting cars, recognizing human face. So basically, and then, well, we need to know how to teach the computer to understand some kind of images. All right. And then there are lots of common things, like, detecting some edges, understanding some kind of, uh, colors, or lots of different things in the world, in the real world. So usually, and then, well, some big companies and using huge amount of data and then using huge amount of computing power, and they are generating something called base model. All right. It's like, we are teaching the computer how to recognize some kind of object in images, some kind of in a generic way. Because it's a general way, well, we need to prepare lots of different cases, all right? Lots of different images, lots of different objects, lots of different cases. Like, car, and then, well, we need to provide some images of the car from all different directions and different lighting conditions and different models. All right. So fundamentally, yeah, to some individuals and small companies, we cannot do that. But well, the big companies, and then they are developing this kind of, big, model called base model. And then once we have the base model, then using the base model, and then we can develop our own the image machine learning model. And then sometimes it is called a kind of customized one, or some specific the what uh specific kind of the object. So this base model is quite important because, well, we don't need to repeat some fundamental things. Okay. So how to understand some visual features? Already the base model has it very well, actually. And then, well, we can save lots of time and then computing power, because the base model already understand lots of different objects. All right. And then sometimes it is called plug and play. And then you're using the base model, and then you can customize it for many, many different things. So detecting cats, detecting cars, and then detecting people. All right. But well, if you, you need to understand that. So for example, even though, and then human beings even, yeah, we can see and we can identify some specific object. But for very specific application, like, yeah, I want to classify the type of car. then normal people, we may fail to recognize some specific type of cars, right? Even though we know that is a car. So we need to train to understand some very specifics of the type of the car, right? So extra training is required for some certain purpose. So similarly, even though we have base model, yeah, we can recognize lots of generic things, but if we want to do better to detect some specific object, yeah, we need to perform something called fine tuning. All right. And for that purpose, and we need to prepare our own custom data set. So again, if you want to recognize some type of cars better, then, well, based on top of base model, we are preparing some more data about some specific types of the car, and then we are adding some extra training. So in this way, and then we don't need to start from the scratch. And then, yeah, we can quickly develop our model for some specific object detection. And usually that is provide some higher accuracy than base model. So lots of people are doing similar things. So in this way, we can save training time, computational cost, and then well, using some relatively small amount of custom data set, you can develop better model. All right. The whole concept is something called transfer learning. So we're gonna reuse the knowledge from the base model. All right. And then many times this achieves better accuracy. So we are doing the same things. The YOLO is one of the base model for object detection. So using YOLO means, yep, we are reusing all the knowledge embedded in YOLO in recognizing, yep, the object in images. All right? Is it clear? Okay. So there are many, the base models, and then YOLO is not the only one. So depending on different types of, machine learning. So for example, image classification, there is something called ResNet, and then EfficientNet, something like that. For the object detection, yeah, YOLO is quite popular. And then there are some other, so for example, RCNN, fast RCNN, something like that. Even YOLO, inside the YOLO, there are multiple different versions depending on the target size of the program. Nano is the smallest one, and small, medium, large, and something like that. So I'm recommending you'd better use YOLO the nano version. This is a small model immense, and then the amount of computing power required for fine tuning, and then that can be the minimum. All right, so this is a kind of case study, and then yeah, if you want to detect some trash cans, trash bins in the street photos, and then you don't need to develop the model from the scratch. So you can just take pre-trained YOLO version. So for example, YOLO version 8, especially some nano version, and then you just download it, and then using that you can just fine tune. It means preparing your own extra images, label the images with ground truth, and then let YOLO add some more knowledge about the task. Yep. Well, the point is, YOLO already understand, what is object, and then how to detect some object, and then draw some bounding boxes, and then some prediction models, and then you have, YOLO already have, such capacity. And then you are focusing on some specific object, and you want to detect, all right, with small number of, the images. So, and then, yeah, again, I'm recommending to use in YOLO version 8, especially some nano version. And then this is tiny, but still very powerful. And then on your even computers, and then you can learn this kind of, the training. All right, so just skip it. Yeah, this is the kind of, the process. Yeah, you start from, with, pre-trained base model. you select one, and then you need to prepare your custom data set and then the labels, the truth. And in our projects and then in our hackathon, even we are providing this kind of custom data set. All right? We are providing all the training data set and then test data set with labels. So you don't need to prepare data even. And using the prepared data, and then you just run the training. It is called fine tuning. All right? And then it's gonna generate program, model. All right? Then you just use that model to detect objects when you provide some new images. All right. So this is the process. And so this is a kind of simple the example. So from the base model, we are fine tuning and generate. So yeah, the program itself can be this much simple. So this code means, and then well from Ultralytics, and we are importing YOLO, and then you just select the YOLO version. And then by calling this one, yep, well, we just get the base model. And then using the base model, we are training. And then we are providing the data. And well, Juyong already explained that the YOLO requires some specific in the format of data. So we need to create in a YAML. We need to prepare the YAML data. And from YAML data, and then YOLO knows, where is the images, where is the labels, and how many classes, what is the name of classes, something like that. And then this epochs, and I will explain this, in the following slide. And then, well, usually in fine tuning, and we are play with this kind of epochs. So basically, the meaning of epochs is, yeah, how many times we are iterating the, learning the entire image data set to enhance the accuracy. All right. And then the final result, the model, the meaning of model means something called in deep learning. And then we say that in a weight. And then, well, it's gonna generate lots of weight, and then it saves. And using this weight, and then, yeah, there are lots of computations internally, and then it's gonna generate the prediction. So, the key point here is, the multiple epochs, and we are prepared, we need to provide, the specific number of iterations. So for example, one epoch, means one complete pass through the entire training data set by the model. So when you have 100 images, one epoch means, yep, we're going to read 100 images and then perform some adjustment of weight. That is the training. But usually we are not using only one iteration, and we are repeating the same process many, many times. So epoch 3 means, and we are repeating the same thing 30 times. So every the epoch we are updating, yeah, the model. The expectation is the accuracy gonna be enhanced. All right. So then, well, inside each individual epoch, and then we can break down, well, the total number of images, and then in a small, the batches. And then we need to define the size of batch. So for example, 16 images can be one batch, and 32 images can be one batch, something like that. All right. And then internally, and then for each batch, and then well, the model, the base model is updating, the weight, and then try to generate some kind of, the new model. So, usually fine tuning means, and then you are playing with, this kind of batch size and epoch, number, and then input image, what size, and you are repeating the training the model, and then evaluate the model, and then, well, when you achieve some, satisfactory the accuracy, then you can stop it. All right. That is a kind of general the procedure. Okay, so again, well, the using a base model, and then yeah, because there are lots of the beneficial is very faster and easier, so we don't need to start from the scratch. and then we are using this one. All right. Then actual fine tuning using YOLO, and then I'm gonna provide some simple example. So again, the concept of fine tuning. So especially in the context of object detection using YOLO, it means, and then we are processing uh, from the pre-trained YOLO model, and then retrain the base model using a kind of new data set, extra data set, all right, for some specific task. And then, we are generating a kind of better model than the base model. That is called fine tuning. All right. Again, the analogy is, general people, and we can detect lots of objects on the street, for example, right? But if you want to, create some kind of, train some kind of expert to detect some specific object, all right? Then the experts, the ability to detect some specific, the object, something like, trash items on the street. And then, we are expecting that the experts can more accurately detect some trash items on the street than the general public. Make sense? Yeah. So fine tuning is, basically, something like that. So fine tuning involves, definitely we're going to inherit the lot of knowledge, that is represented by the weight, and then from the base model, and then we are updating all those weight from the new data set. Hopefully, with a small amount of computing power, all right? Of course, sometimes it takes lots of computing power depending on what kind of, application, what kind of training you are performing. But, this fine-tuning process should be much faster, much cheaper, all right, than developing the base model. So in your YOLO, and then, for fine-tuning, we are following and this kind of steps. So some part you already know, and we need to install the YOLO, and we need to prepare the data. You need to create in a YAML file, because without YAML file, YOLO cannot understand where is the data. And then, now you are just executing YOLO for the training. You already saw the code, and then, with some kind of parameter values, and then that is fine-tuning step. After fine-tuning, and then it's gonna generate one model, all right? Again, the most important thing is, we are not expecting any model. We want a good model, right? How actually we can create the good model? Before generating good model, we need to understand what is a good model. So we need to evaluate the developed model is good or not using some, the metrics, something like, accuracy. All right. And then, if you are satisfied with the accuracy after evaluation, you can stop it. And now you can use that model. If it's not, then maybe you can repeat. All right. By playing with some parameters. All right. Or sometimes, you can even change the data set. All right. So installation is that simple. And preparing data set, the Juyong already provide this kind of format, and then the folder location, because YOLO is expecting this very specific, format about the location of the data. And then also, we need to provide the label, the ground truth, and then it requires this kind of format. So Juyong already show, this in the code. The purpose of all this explanation is I just want to provide one full scope, kind of consistent, the presentation about the steps. So some parts it's, repeating. This is an example of in a YAML file. So the location of training data, and then location of validation data, the number of classes, and the name of classes. It's pretty simple. But you should prepare the accurate the location. All right? Then the training itself, yeah, is this much simple, especially when you are using YOLO version 8. All right? Simply import it and then select the model. Then this model variable is the base model. And then using the base model, we train. Again, using the data located in this YAML file. And then we can provide the epoch number and then input image size. All right. So in this example, well, you have two input parameters and you can play with only two input parameter values. All right. So fine tuning and then, you need to understand what's the meaning of, this epoch and what is the meaning of this kind of, image size. All right. And usually, depending on the input parameter values, yep, usually we can play with uh, the training speed or versus, the accuracy of the model. When you put, some values and then your training time can be pretty long. It means it's more expensive training, and then we are expecting more accurate the model, or vice versa. So in general, and then they are recommending, yeah, this is a kind of, suggested epoch, number for some small training, less than 1,000 images. Yep. Some, the iterations between 50 to 100. Some medium from 1,000 to 10,000 images. And then 100 to 200 epochs. And then for the large cases, more than 10K images. And then, 200 to 300. But remember that this is a suggested epoch in the industry. All right. So if you want to learn lots of the epoch repetitions, and maybe on your computer, yep, it's gonna take lots of time, maybe hours and days and weeks. Okay. So usually, and then we are starting from some small number for epoch. All right. And we can quickly check, oh, if this training makes sense or not, and then well you can check the trend, and depending on that you can increase the number of epochs later. All right. And then about the choosing the image size, and then depending on the input image size, and then the size of image means when you provide some image, the base model, and then they just resize it and then take it as an input. All right. Even though you provide really high definition images, and then the base model YOLO gonna reduce the resolution based on the image size you are providing. So there are common size like 416 and then 640 and then greater than 800, 1024, something like that. And then there is a pros and cons. So small image size means the training can be faster, but well we can expect lower accuracy, especially for what? For small object. Small object means appeared small in the image. All right. Because the resolution is not that good, identifying some small object which has some small number of pixels, and then it's basically difficult. And then default value is 640. So usually, this one is providing some kind of balanced, the result. The speed is reasonable, accuracy is pretty good. So lots of people are using this default size. But sometimes, you have high quality images and then you want to detect very small object. You want to have some very accurate detection. Then, you can use bigger image size. Then the training time gonna be very long. It requires lots of computing power, but the resulting model, yep, the detection accuracy can be more accurate. So in general, our suggestion is, usually we are starting with some default value, all right? And then occasionally, and you can go higher. And then if you know that you're going to detect a very small object in your images, or you have very powerful hardware. So even though, and then if we are using high resolution images, and the training time going to be shorter. Or you can go lower if you know that, oh, the detection speed is quite important, or you have some kind of limited amount of computing resources. So for example, your computer is too slow, then maybe you just reduce, okay, the input image size, to save the computing power, to save what? The training time. All right, again, so this is a revised, the program. It means, yep, we can provide some more input parameters, not just epoch and then image size. Yeah, we can add something called batch. Do you remember that? Inside one epoch. And then, well, we can further divide the number of input training data. And then, well, we can call something called batch. Batch is the actual kind of yeah uh, weight update happens based on the batch. Batch is the unit of weight update. And there is something called patience. So this is a very interesting concept. All right. So for example, when you iterate 100 times, and then your expectation is more iteration, more epochs means higher accuracy, but not always something like that. All right. After some certain epoch, and everything can be converging, it means the no enhancement in the accuracy. All right. Then why we need to repeat? So for example, you put epoch number 100, but after 30 epochs, well, nothing changes. All right. Nothing changes in the accuracy. But well, you have to go 70 more epochs. It wastes computing power significantly, right? So the patience means, yeah, you automatically detect if there is an enhancement in every, the iteration. Then if there is no iteration enhancement in the consecutive 20 epochs, then just stop it. Don't go to 100 repetitions. That is the concept of patience. All right. So sometimes, yep, when you use this kind of patience, you can save time and then computational cost. So usually, and then well, we are recommending you can start from some small, number of iterations and small image size. Okay. And then after getting the result and then evaluating the result, if that is promising, yeah, you can just scale up. That is the usual way. All right. Because from the very beginning, and if you put, huge numbers in epochs and then bigger size, and then, well, what happened? After that, not necessarily more repetition gonna generate, better result. All right. It's a waste of, computing, the power. All right, the next thing is, well, then, when you have lots of parameters, and how do you know, well, which one is, yeah, the correct value? All right. So in general, nobody knows. Sometimes it is like, trial and error. If you're lucky, and then, well, small number of trials, and you want to get some satisfactory model, and you can stop learning. If you're not lucky, and then you need to try lots of different things, all right? Or still, you may not achieve, the expected the accuracy. So in general, it's a kind of interactive way. While the training is going on, and then you need to monitor what is going on. All right? And then you need to evaluate in the middle. So there are some kind of measurement for the accuracy, the precision, recall, sometimes, MAP 50, and using those, and then, well, you just, monitor what is going on. And well, we have the concept, something called underfitting and then overfitting. Again, well, even though you don't understand, those terminologies right now, okay, I'm just providing some kind of guideline in the next, 2 weeks, and using all this, the explanation in this slide. And sometimes you need to study by yourself. All right. And all these are related to the fine tuning. It means enhancing the accuracy of your models. All right. So right now, if you don't understand what's the meaning of underfitting or overfitting, don't worry, because you have this slide and you need to go and then check what is the meaning of underfitting and overfitting. All right. That is the way, and then you are learning through the project. Okay. So underfitting usually means, okay, yep, your model is not performing, very well. Overfitting means your model is, working too well. That is also a problem. Why? If your model is generating 100% correct answers for the training data set, all right, then it means, and then your model is too much focused on the past data or some specific small set of data. It's not general. When you have some kind of new images, maybe your model is not predicting well. That situation is something called overfitting. All right. So for different situation, and then there are some different way you can try to enhance the accuracy. So, well, in training, and then in order to achieve some desirable accuracy, and then we are using this kind of validation step. So when you have data set, everything is labeled in the data set, and then we can divide this into two groups. One is training data, one is validation data. And using training data, we are developing a model, and using validation data, and we are testing if the model is working well. Validation data is important because the model didn't see the data in the validation data set during the training. All right. So once the model is trained using trained data and still it is working with some new data set, validation data set, and then produce some good accuracy, then it means, we can say it's generalized and it's a good model. So always, we are doing this. Okay, using trained data set, we are developing the model. Using validation data set, we are testing it. After testing, if the result is good, accuracy is good, we can stop it. If it's not good, then what happens? Again, retrain using different parameters. All right. And for, accuracy measurement, and then we are using some popular some measurement, something called MAP, that is mean average precision. So you can generate it easily by calling this kind of function. All right. The Python, the UltraText and the YOLO and packages, and then they just calculate all this for you. All right. And then we also have, another concept, something called the validation loss. And then this means, the difference between, the predicted, the prediction and the ground truth. All right. So, well, when YOLO predicts something and then it detects some object and then making some kind of bounding box and then provide some kind of, the class, right? So for example, detecting cat, around the cat, it makes some bounding box and then it say that, okay, there is your cat. All right? But what if they are different from the ground truth? And then if they are very different, and then, well, we say that the loss is high. All right? If that is very similar, okay, the loss is minimal. And then we can consider, multiple different types of the loss in object detection. So box regression loss means, yep, two bounding boxes, and then they are not, matching, very well. Okay? That is the difference between prediction and ground truth. The classification loss means, yeah, we predict something, but that is not correct. All right? So for example, we detect cat and dog, and then we detect cat, and then model says this is cat, but actually that is dog, right? Then that is another error. That is a classification loss. And another case is, yep, the objectiveness in the loss. This means, how well the model guesses if an object is present. Sometimes we are just missing it, right? Then missing means what? There is no bounding box, there is no classification, but that is error situation. All right. So using this kind of metrics, and then we can also discuss the accuracy of the model. Yeah, so this is kind of repetition. So how actually we can decide the number of epochs? So, well, the choosing the right number of epochs is very important because too few epochs, and then the model is not providing good accuracy, and then well, too many epochs, then yeah, it generates some problem, something called overfit. It means, yeah, it just focus on the training data set. The generalization is not good. Maybe it's not working very well for new data set. So, well, the best number of epochs, and then yeah, it's gonna provide all these good things. But well, the number of epochs, it varies depending on these factors. So for example, the size of image, the quality of the data set, no, size of the, number of images, the quality of the images, and the complexity of your model, and then the batch size, yeah, it all affect in deciding the number of epochs. So even though, well, there is no, you know, clear way or royal, way to decide the best epoch numbers. But in general, yeah, this is a kind of common strategy people are using. All right. And then, yeah, but previously I explained the concept of patience, and then that approach is something called in early stopping. So even though, and then you provide some big epoch number, but you're gonna provide some patience. It means, well, for some number of epochs, nothing changes, and automatically it just stop. It doesn't go to the entire number of epochs. All right. Or sometimes in the world, we are using this kind of validation loss curve, and then usually, and the YOLO is providing this kind of curve while it is being trained. You just monitor it, and then you can stop it. So maybe, well, this is somewhat advanced topic, and then yeah, please study some more about this issue. And then again, the basic approach is, yep, from very beginning, don't use big numbers in epoch. Okay, use some small number, and then check if you can create any kind of model, and then if you can generate any kind of what accuracy. All right. And if that is not satisfactory, and then maybe you can try some bigger, the epoch number. All right. Yep. That's it. So what do you think? Well, maybe well, you cannot follow, all the details right now. But again, the whole purpose of this, presentation is, this is the basic steps. You need to following these steps in the competition. All right? Because, well, it's not like, you just program once and then run and once and then generate one model. That is not it. All right? You need to evaluate your model, how accurate your model is. Usually at the very beginning, it's not satisfactory. Then you need to know how to improve the accuracy. And I explain, some, suggestions. Okay. Okay. Any questions? All right. So maybe you just take, some time to, digest, these materials. Okay. And then, I'm going to stop, sharing. All right. So, and then, well, yeah, now, yeah, I need to check a couple of things. Yeah, previously, Ju Young provide some really simple, the machine learning case, object detection case, I mean, the detecting cat, right? So how many of you were successful in learning the Ju Young's code and then generate a model? Yeah, everybody should answer this time. I'm gonna go, uh, yeah, over, the order. Daniel,
Yes.
so were you successful or not?
Um, I guess, but like I had some trouble like figuring out like the like some part of the code
Okay.
because like it wouldn't like run.
You tried, but some part is not learning.
Yeah,
So, did you try, line by line or just, try to execute, the entire program?
line by line.
Okay. Then, so you have problem at the very beginning or in the middle or at the last
I
moment?
think in the middle.
In the middle. Do you know what
Yeah.
exactly?
Um,
Which line, something like that? Okay, so good. So yeah, be prepared. All right, you need to show where you have some problem, and then maybe GM can help you, okay? Or Christina,
okay.
you were successful, right?
Yeah, mine worked.
Okay, then maybe you can also help. All right? All right, then Samuel, how about you?
Yes. Oh, wait. I actually joined late because I didn't know there was a meeting today. I'm just still trying to catch up with all the lecture, but once I'm done and then troubleshooting the code, I'm gonna try to see if I could talk to you and maybe you could help me troubleshoot if there's any error.
Okay.
Thank you.
Yeah, so well, we are talking about, you can access the shared, drive, right? You can find, the tutorials and
Yeah,
then
yeah,
data.
yeah. Going over the lecture right now.
Okay. Uh, Lion, Rayon, Lion, how about you?
Yeah, I'm still trying to understand some parts of the code, but I got the model working,
Okay.
like it's generating the images and stuff.
So you generate the model, and then you can execute model for new data.
Well, I haven't tried new data yet though, so I've
Okay.
only done like the
All
the
right.
one I was getting.
Yeah. So there is a kind of two parts. One is training. Another part is actually you need to use. So it means, yeah, using the validation data, you need to generate all those predictions, and then you should be able to generate some kind of accuracy metrics. All right. Okay. Good. At least, yeah, you are successful, and then you try to understand some more details, right? Of course, it takes some time. Yeah, that's fine. Okay, Julia. Julia, are you there?
Yeah,
Mm,
I'm working on it, but it just told me that there's like a lot of errors.
okay. So
So I'm
maybe,
just trying to fix it.
mhm. So maybe, well, Krishna or Juyong, and then you can help, where is the problem? Okay? It's a kind of one-to-one. All right. Yudam,
It worked, but
I cannot hear you. Yeah. Can you say again? Okay, then. Yeah, you can answer on the chat box. So what is your progress? Okay, it was working fine, but I didn't understand some of it. All right, so that's fine. And then, well, the whole purpose is, we need to understand what is going on. All right, by the end of, the hackathon day. So you have 2 more weeks. All right, okay, that is fine. And then next, and then Aiden.
So I ran into some trouble like rearranging my files so that the YOLO could read it. And then after I put it in, my computer froze, so I'm still working on that.
So arranging files, it means, and then you maybe cannot find the location of files.
Yeah, so it got moved to a completely different file, so I had to kind of sort out where it was.
So did you follow, the exact the folder structure?
Yeah, but I don't know why, but my Finder is kind of weird. It downloaded into a completely different folder instead of downloading into my Google Drive.
Okay, so maybe, yeah, we can check it. Okay, Urin.
I'm still working on it because I'm trying to understand the code and then like write it, but I'm not getting most of the part. So
Okay. All right. And how about Jaden?
I was having some trouble and I'm a bit behind on lectures because I missed some. But
Yeah,
I'm
so
still
what kind
figuring
of
it out.
trouble, you have?
I'm just getting along with errors and my progress got deleted twice. It just stopped saving, and then when I tried to reopen it again, everything was gone.
So were you able to, yeah, for example, some lines?
Yeah, I was, but no, it's like there was like an error message that popped up that said that it stopped saving and just reset everything.
Okay. All right. So then, let's see, what can be the best way? So, I think there can be some kind of common problems. All right. So,
Yeah, I'm still working on it though. I'm gonna try to like go back to previous lectures and see if I missed anything, and then I'll try to figure it out.
I think, at this stage, yeah, rather than advising the individual program, so let's do this way. One student gonna show code, okay? And then try to learn the code, and then line by line, and we're gonna confirm if that is accurate or is there any kind of questions, any problems, and then maybe Juyong and Krishna, and then we can answer. All right? In that way, and then everybody, can follow the line by line code. All right? And then they can compare the code with your own actually the code. Then after that, if one student is successful and then still another student has one problem, then we can check the another problem together. Is it fine? Juyong is fine?
Yeah, I think.
Okay. All right. Then let's do that. And then, well, we're going to have some kind of short break, maybe 5 minutes. And we're going to return on 8 p.m. Okay. And then, yeah, we can start that kind of group discussion. All right. 5 minute break. Okay. Yeah, please come back. Let's just start. All right, so yeah, this is important. So everybody, please, be focused, and then you need to know that, and everything is recorded. So later, whenever you have some questions, please, 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 watch the video. All right? Okay, so yeah, who gonna start first? So I want to start, somebody, and who did some basic things, and then some problem maybe in the middle. So how about Daniel? Can you start?
I'm trying to open the Google Colab. I'm like downloading something.
Downloading something now?
Yeah.
Okay.
Wait,
All
hold
right,
up.
then, yeah, who wants to try?
Well, I'll let you know when it's fully it's like done.
How about, yeah, who has some issue? Yudam? Yudam, are you there? Okay. All right, how about Urin?
I'm still in the process of understanding the codes, so I don't have like a solid one.
Ah, I, I wonder, anybody, install the program and then try to learn the, code? If you actually tried to learn the code and then definitely, and then you can show anything, right? So you don't need any help?
We just can start from the scratch.
Okay, then, yeah, who want to start from the scratch? At least, who has the core app, and then, yeah, can execute, download, the data, and then can execute, the code.
Anyone can just click the link on the chat box, the collab links on the chat box. Anybody? Anyone can start from the scratch. Volunteer.
I could do it. Should I just share my screen or something?
Okay, yeah.
Do you see it?
Yeah.
Mm-hmm. Yeah, so, yeah, can you say something? So you just try to explain, yeah, based on what you are, understanding. And then maybe, and then, so others can give some, the correction or some kind of comment, something like that.
Oh, so just like try to explain this?
Yeah, so from the very beginning, yeah, just based on your own knowledge. And then if you
Okay.
don't understand, and then, yeah, we can add some explanation. All right? So
All
let's
right.
go.
So
Yeah.
for now, I think this just connects to your Google Drive. Ooh, what? Oh. And then this one installs Ultra
Yeah.
Analytics.
Go slow, because some others, and then maybe they don't know, all right? So I just want to use this as a kind of learning materials. So go back,
Right.
So that the first the line, from Google Colab, and you are importing the drive, and then just provide some location, all right? So it means your program gonna access the files in that specific location.
Yeah, and there's another line on the top of the code. So you might need to change your runtime time. I mean, should
right.
read, it's the default value, but you might need to check this one first.
So it means you can select what kind of hardware you can use, right?
Yes, right.
You're using GPU and it's faster, so you'd better select the GPU. All right, the next one. So now and then you can access the data. Then so going up, that part. Then you already installed Ultralytics, right?
Yeah.
Okay.
Should I continue?
Yes, just try to explain it as much as you can.
Okay. So what I think is going on here is it just installs Ocean Analytics so you could make your model, and that's pretty much it, I think.
Jian, please add some more content because
Yeah.
we need to explain line by line here.
Yeah, so from the top line, this one, the install Ultralytics, it's kind of installing Ultralytics on the Google Drive, on your Google Colab right now. So we're gonna install the Ultralytics with this code, and these are just second and third ones are for beautify our the cells, and just import the Ultralytics with import Ultralytics, the fourth code, and the using the fifth code to check the Ultralytics are installed well or not. So if you can see the setup complete lines below the codes, then it means we installed Ultralytics
Correctly,
correctly. Right.
So you are ready to use, YOLO.
Right, exactly.
Okay.
And I don't know what these lines do, but the last one just unzips your data set.
Yeah, right. So for the first line, it'll be make directory the command. So mkdir means make directory on your Google Drive. So contents under the contents drive and my drive, it will be the default, the folders of your Google Drive. And then you're gonna make the YOLO underscore tutorial folder and change drive into that folder. And
but those are the commented out, right?
oh no, it's under to download the cats and dogs dataset.
Oh,
so
okay.
These are the third one is like this one is the cats and dogs zip files, the original link. So you can just use this the GDown with this specific the code to download Google, I mean cat and dogs, the dataset zip file, and change the directory again to download this the zip file into the YOLO underscore tutorial folder. So using the unzip and QQ to unzip the zip file with the cats and dogs dataset folder. So these are
So actually, well, you don't need to repeat this kind of downloading and unzipping every time you are executing the program.
yes, right. So that's why the Google is saying, do you want to replace this YAML file? Yes, no, or something like that. So you don't need to download again this one. If you already download this zip file and this this zip file into your Google Drive folder. So you can just no and all will be better. Can you just type A?
Oh yeah.
Capital A. Yeah. So can you open this the bottom? Can you click this bottom?
This-
Oh no. The folder icon.
Oh, the folder.
Yeah, folder icon here, and click this one. Drive, and there's a My Drive, right? And you can see the My Drive. Under My Drive, you can see you can find YOLO underscore tutorial. Yeah. Can you click this one again? And you can check this folder. And can you open this one again? It takes some time to open the folder, or you can check this folder from the Google Drive itself. Yeah, there's a test file, train, and the data YAML file was downloaded using this the code.
Okay, so all downloaded, and then yep, the location is confirmed, right?
Yes. And to open the YAML file, you can use this code, this line, the cat command. So you can just click this one to see the YAML file. Yeah. And you can also see the YAML files, the contents, using double click this file. Yeah, here. You can see these are the same contents, right?
Okay, so if everything fine, then maybe you don't need to execute this kind of cat and then the YAML file.
Right.
So yeah, the cat simply means, and then we just want to display the content of the text file.
Yes.
All right. But well, if you want to, check if everything's fine, then definitely you can, execute this cat command and then check the content of the YAML file.
Right.
Anyhow, this is not the necessary part.
Right.
All right. So now, and then it's ready. So the data, they are all in the correct location. Then it's time to train it. And again, the code is pretty simple. And then,
Rayun, so can you just click the run file folder here?
Oh, click it.
Yeah, just for checking. Okay, and click the detect folder. Oh, you did a lot, right? So yeah, you can see it just if you click this train code, like run this train code, then automatically the YOLO, the Ultralytics will create the detect and runs folder here. These are the automatically created by the Ultralytics, I mean the YOLO. So you can see the result here and here. You can find some results using this the runs folder.
And then, Professor, I just had a question.
Mhm.
So I checked the email that was sent from the hackathon with the Google Drive of the images, and they don't have the, you know, the box with the image found. So then does YOLO do that for us, or do we have to do that separately before inputting that folder of images into
Yeah, so when you generate in the labels, and
Mhm.
then the display of the box, that is option. It's not automatic.
Okay.
Yeah. So, but all the the labels are there.
Okay.
So maybe in the Juyong, you can pinpoint, which code gonna make some kind of boxes visualization.
Yeah, I will. So yeah, the training has been completed.
Can you just, explain what is this, the messages? Just select one of them. So for
Okay.
example, I already explained what is the meaning of epochs, right? So left side, that is the number. Yeah, you provide number 20, so it's gonna iterate 20 times. But 10 over 20 means 10th epoch out of 20.
Yes.
And then you just provide some kind of statistics. Yeah, the memory, GPU memory, this much has been used, and then loss is this, and then yep, okay. And then if you understand, those are the numbers, then you can check how your training is going on. All right. So
Geometry, can you also explain what like YOLO does during the training process? Like exactly what is happening to the images? Like when the alterations are run?
They're gonna reduce the loss, and they have something like the values to train the images. So they're gonna reduce that. They're gonna change those specified by the YOLO model. The
I
structure.
don't know, Krishna, what is your question exactly? So you want to know how YOLO is working?
I want
Or
to know, so when we run this training code, I'm understanding that it's going to take the images from the Google Drive and then use that to train the YOLO itself, right? So
yeah.
it's able to figure out, oh, there's a cat here and there's a dog here. But I'm curious just like exactly what this lines of code are doing exactly to like in that process. Like so how is that happening?
Yes. So understanding how, deep learning model is working, that is very complex. All right. And then, yep, you need to understand, the very complex mathematics.
So it's not important for the kids to know that, right?
Yeah. So right
Okay.
now, and then that's why I'm saying that it's a black box approach.
Okay.
Right? So you have something called YOLO. It's a black box.
Yeah.
So you
So
provide
guys,
the
you
input.
don't have to stress about like understanding everything, just just knowing that this is what's happening.
Yeah.
So don't stress out too much. Yeah.
Mhm. Yeah. You don't need to understand, the internals of deep learning model.
I can just briefly the metaphor of deep learning, this kind of YOLO things. So if you have this kind of cats here, and here the epoch's gonna be like they're gonna make like this kind of box, but there's some the blue box is the answer key, right? So they're gonna predict the cat as this kind of bounding boxes, and after the epochs, between this box and the blue box, they have some gap, right? So these are called loss. They want to reduce this kind of loss. So after like 11 epochs, they're gonna train their own algorithm to get these kind of closer bounding boxes. They're gonna move to reduce the loss to train the specific model. So these are the metaphor for the YOLO training.
Great, you can
Okay.
move on. Yeah.
Oh wait, what? Sorry, my audio cut out for a little.
It's okay, you can move on. I think we're done talking
Oh,
about
okay.
the training part. Yeah.
So after training, okay, can you go up a little bit? Okay, here. So it just say that the result saved to learns, detect, train 3. All right.
Yes.
So it means the developed model can be found here, right?
Right.
Yeah. So then, next, and then you need to use the trained model. All right.
Right.
That is the prediction part.
Yes.
Okay. So let's go to the prediction. Yeah, again, the first line, import in a matplot, that is for the visualization. It's nothing to do with the actual, the prediction. All right.
So
And
Ray,
then,
if you want to use the recent model, you might need to change this one because we train the best.pt file will be here, right? So you might need to change this one to
So
use.
like this.
Yeah, right, exactly.
yeah, because the most recently developed model is located in train 3.
Yes, right. Exactly. So you can, Rayan, you can just click this one, this folder, and you can find the best.pt file under the weights folder here. Oops. Yeah.
The best.
Yeah.
And that is the actual model.
Exactly.
Yeah. And YOLO has some kind of default name, the best.pt. So you have to use it.
Yes, right.
All right. Now and then, you select, the newly developed model. So the model variable now, then that is the newly developed model. Then now and then you need to provide the path to the test image. So you have long, pathway to the test images. Okay?
Yeah.
All right.
Should I run it?
Yeah. And then the for loop means, and then you are reading image by image, and then you are making the prediction.
Oh,
Right?
yeah, right. I didn't put the flow file on here. Just a moment.
I think I could fix that when I run something all the way down here.
Yeah,
It's like
under the
this thing.
right. Yeah.
And then if I do this again,
Yeah.
I think it should work.
So the YOLO model will predict the images one by one.
Mm-hmm.
So using this best.pt model to predict the specific images.
And so inside the for loop, and then there is a result and the model.predict. The model is the newly developed model, and dot predict means, and then we are taking new image and then perform the actual prediction.
Yes.
The result goes to the result.
Yeah.
Okay. And then when you call, the developed model, and you need to provide, the source image file name, and then the size of image, and then save true means, what is that, Juyong? The save is true.
They're gonna save the predicted images. So you can see the saved file from the
Okay.
predict for
The
folder.
result is stored there. Yeah.
Yes, right.
Okay, so yeah, but how many, the test images you have?
Maybe 12 or
Yeah, there is a question
yeah.
in the chat box. I don't know why it says globe isn't defined.
You can just click the I'll fix it, but Rayan, can you just come down to the import code, like
Oh yeah, this.
yeah, here. And just here is the import globe. The code was missed. So yeah, you can just Summer, you can just click this button, yeah, post, and then you can solve this problem. Yeah. So there's a 10 testing images here under the predict folder. Yeah, Rayan, can you just go up?
Oh yeah.
Yeah, here. So predicted images are saved in here. So you can see these results. So can you just double click the test, the first image? Yeah. So the original image doesn't have this kind of bounding box, but after model predict original images, then they're gonna save this kind of bounding box.
Yeah, again, this kind of visualization is optional, right?
Yeah, right.
Usually, and then we are not doing that because when you have huge amount of images, and then we don't need to visualize it. So this is just for our own interest, right?
Yes.
So which line is actually drawing this kind of the box?
Just this option.
Where?
Say
Okay, save true, and then it's gonna put the actual box, all right?
Yeah.
If that is false, and still it's gonna save the detection result in a text file, right?
In a text file.
Yeah, so
Yeah.
this save is true means, and then it's gonna record the result in a text form, right? But this visualization, and which code is showing this visualization?
Save true is the visualization, but
Okay.
they didn't save the text file yet. Just a moment.
I don't understand.
They don't save the predicted text file automatically, so we need to put another the parameter here. I'm gonna give you another parameter. I just want to show the this kind of outputs very directly.
So for educational purpose, and this is good, but in reality, and then we are not saving this kind of images because it requires lots of time and then resources, right?
Yes, right. So Rayan, can you just change the save
to false?
To yeah, first and comma with save underscore text equal true, like it's on the at the chat box.
Yeah, see the chat box. Chat box.
Like this?
Uh, without this, yeah. Can you just run again?
Run it again. Yeah.
Yeah,
It's much faster.
right.
And then now
And
the
then now,
result is saved in a file, something called labels.
yes, right.
Okay, can you go there?
Oh,
Gonna be in Predict 5, yeah.
Yeah. Mhm.
you just double click this
Yeah.
file.
Okay. So, yep, the text, the result is stored here. And in reality, usually, and we just use this one because this is enough to discuss about all the accuracies. And we don't need visualization of, for example, when you have 1 million images, right?
Yes.
Yeah. But well, still, this one has all the information. Using this one, you can manually draw the box too. Okay? Yeah. Okay. So move on. So we predicted it. So we generate the result. And then what's the next step?
These are the visualization part. So I just visualize the predicted images in the front on the Google Colab. So there's no images because we turn off the image predicting imaging. We only have the fourth the folder. Yeah, that one. And you can just change this one with the second imaging. Then you can see the result here. So this one is the only for the visualization, right?
Okay. Yeah, so there's a question.
The chat, it says, how come for the Predict 4 we got 10 visualization, but when we ran the save text, it only gave us 9?
Means there's no cat in one
One
image.
of the image.
Yeah.
That makes sense.
Model didn't predict any cats in that specific one image.
Is that supposed to be correct? So does one of the images not have a cat in it?
Then there is no prediction, then there is no reason why, and well, to save, such a things. Yeah, again, for some efficiency. In reality, and then when you detect something, usually we are not detecting anything.
Yeah.
All right. So we don't want to, so basically it means, by default, not saving, it means no detection. Because there are lots of, no detection cases. Okay.
Yeah. Another one.
So this is the visualization.
Yes.
Okay, then what's the next?
And the
Yeah,
last
generate
one.
performance metrics.
Yes, right. So to get the performance metrics,
Mm-hmm.
we are using not this folder, the file. So we need to change this one. The third one. Yeah. Just click this one. Yeah. So
Yeah, basically this means, and then you need to find, which model you are using, and then you need to provide, where's the validation data set.
Mhm.
All right. And then, yep, you need to generate the result, and then based on that, generate the metrics.
Yes, right. Exactly.
So this means, and then you just keep the prediction part and then directly generate
The metrics.
metrics.
Yeah.
So it means the prediction is already done, and then it's a little bit confusing.
The prediction and the validation is separate. So this one is testing.
So this one means the prediction is already done, right?
Yes, right.
In the previous step.
Yeah, right.
And the result is stored in yep.
The results are using our model, which was trained by
This is the model.
Yeah.
Okay. But where is the result?
And the result is here.
No. The prediction result. To generate this matrix, and we need to have some prediction result, right?
Oh, right.
Where is it?
I'm using the prediction as a just prediction result only. So they don't have any labelings. I mean, the prediction is not they're not giving us the result, like the labelings or something like that. The metrics. This looks a little bit confusing, but
So you mean the model.val,
mhm.
and it include prediction too?
This one?
Yeah.
This one is the testing, like the splitting using the testing data set. So how can I explain it? So we have, how can I type it? So we have train, validation, and testing, and also the prediction data set folder. So the prediction, they don't have the answer.
So where did you type? On the chat box?
Oh yeah, here.
Okay.
Sorry. So the prediction code doesn't have any answers. So it's like I'm using the testing data set, but we don't need to calculate the matrix using the predicted output. So I divided into prediction and testing separately. So
yeah, but the code right now, and then you says is separated, but there's no step of prediction. So the first line is just model, and then you just say, I select in the best.pt, right?
Yes.
And then model.val, and then you just select the data set.
Right.
Then where's the prediction part?
They automatically predict and get this kind of value.
Yeah, so that's my question, previous question.
Sorry.
Model.val,
Yeah, right.
it includes both prediction, and based on that prediction, generate the metrics.
The metrics, right? Exactly.
And then they are not really storing the prediction result, because that is intermediate values, to generate the metrics.
Metrics, right? Yeah, exactly.
Okay.
Sorry, I was confused. My bad. Yeah. So these are the different, like these are the fully.
Yeah. Wait a second. And can you go up? Yeah. And then let's see the result. Yeah. This is the matrix, and then it is providing the precision, recall, and then MAP 50, and then another one is, yep,
95.
yep. So you need to understand the meaning of this matrix, and based on this, and then you can guess what can be the accuracy of this model.
Right.
The ideal situation is, all metrics are high. The
Right.
precision is high, recall is high, MAP 50 is high, everything is high, then that is the perfect. All right?
Right.
But many times, you see high precision, but the low recall. All right? Then, you need to interpret what is the meaning of that. All right? So later, and then, we can study, some, real meaning of that. All right? Yeah, but our competition, and then we're gonna use, some metrics like, MAP 50. All right? Okay. The next. So far, and then, the one evaluation is done, right?
Right.
Yeah.
So actually the codes are so far is like we did completely done training, prediction, and the testing. So these are the redundant codes. So
Okay.
we
So
don't need
these
to.
are, some extra code for some kind of studying.
Yes, right. So
Mhm.
just to show the training logs here.
Okay.
So when you run upper here,
Okay, so wait. So then, so far, and then we just provide, one single training.
Right.
Okay, complete cycle.
Mhm.
It's not cycle in one pass. So, we just read the train data, and then we just training a model, and then we just read the validation, and then we just generate the prediction, and then based on that we can make some kind of metrics, right?
Right. Yeah.
Now and then when you're in a competition, you need to think about this model is good enough, and you want to submit this code, this model, I mean, or not. How? Based on the metrics. All right. So for example, okay, you don't like the metrics. So then what can you do? Can you go up? Yep. So now and then you have these numbers. So for example, precision 0.72, recall 0.77, MAP 50 is 0.745. All right. Now go all the way back and go to the training. Go to the more training code. No, training code. Yeah, here. All right. So now and then let's try to change some numbers. So how about we are changing the number of epoch to 40. Change it. Okay. Now execute it again. And it takes some time.
Yeah. Right.
Yeah, but within a couple of minutes, and we can see the result.
Yeah.
All right. So this is we are now developing another model. All right. Remember that it's another model.
Mhm.
So with the drive of the pothole images, we
Mhm.
can use the same code but change like the directory that we go to go to that certain drive, and then we can do the same process, correct?
Yes, right. Yeah.
Okay. Yeah. So this is probably all the code that you need, and like what we're going to work on is making it more accurate. So guys,
So
remember that's what we're
actually, I provide another kind of tutorial,
yeah, I
and
saw it
then
on the email.
yeah. So well, it's up to you, and then well, you can use whatever the program. So more simpler one, more advanced one. But the point is, whatever code we are using and generate model, and based on that model, we are evaluating, and based on the accuracy, yeah, we're gonna provide some kind of the rank.
Yeah. So just while we're waiting for it to finish, did everyone get the email from the hackathon a few days ago? Can you all just like put in the chat or raise your hand or something?
Yeah. Yeah, please answer.
Yeah,
Did you
hopefully
all
you got-
received my email about hackathon?
good.
Okay.
Because if you didn't, that means you're not signed up yet. So
Mhm.
okay, good. Jaden got it, Yudam got it, Samuel got it, Ray got it, Aiden got it. Okay, that's good. Yeah. If you
Julia
guys,
is not.
yeah, for the people who didn't respond yet, if you guys didn't get it, send me a private chat and then I'll make sure you guys get it, and then we can move on with the code now.
Okay. All right. So then well, we already have some new model. It's in the train 4. All right. So now and then let's yeah, predict it. Or we can just skip this one and then we can just go to the validation directly, right?
Yeah, right.
Yeah. Go to the validation. And we can skip this because visualization is not really important. Yeah, here. And then you need to put train 4 in the path.
Yeah.
Right? Okay. Can you see the difference? So now the precision is higher, recall is higher, and then yep, MAP 50 is a little bit higher. All right. So now we know that this model is better than the previous one. Okay. So you try to develop 2 models and you compare these 2 models, and then you can select which one is better. All right. So you can play with all those parameters. All right. And even you can play with the selection of data set itself. So for example, how to split the data set. All right. You can control it. And then, well, using this, trial and errors, and then you need to, you record in all these the result, and then you need to select one best one, and you need to submit that model. All right. All right. So we just saw some kind of working, yep, the code, and I definitely emphasize that everybody, all right, you have to try. All right. You need to, yeah, execute, this one by one. Don't sit in front of the computers, okay? So, yeah, definitely, well, the time is up today, and then next week, everybody should provide, well, this kind of try. All right? This is extremely important. Don't be afraid of this. If you read, all the slides, and if you watch all the recorded videos one more time, and follow this kind of, the existing code and execute it, yep, you can figure it out. And then when you face some errors, ask. Krishna, you have something?
Yeah, I just say, guys, seriously, you're really just pressing like 5 buttons for this code. You're not even writing it, right? So just try, open it up. It'll only take like 20 minutes to see it working. And then from there, you can figure out, oh, when I change the epochs to this number, the accuracy changes to this number. And if I tweak this around, that's really the only part we're going to be working on. So, yeah, what like Professor said, don't be scared. It's just you're really just pressing 5 buttons.
Yeah.
So just give it a shot, and if it doesn't work, you have our emails and stuff. So
Yeah.
don't be afraid to
So
reach out.
when there is an error message, and then you just take some screenshot and then just send it. All right? So you can get some help.
Yeah, I just let you know the how to save this code is like today's the lecture's code. So Rayun, can you just click the file button here and locate in a save copy in Drive? Then you can save this code. But if you have any problem with this code, then you can just click the link, the original link, then you can just reset your code.
So it means you can modify your program and you can save the modified version.
Yeah.
And then later, if you have some problem, lots of problems, so you don't understand what is going on, and then you can just download the original code again.
Yes, right.
Right?
Okay. Yeah.
So again, yeah. So basically, you don't need to be afraid of, these
Right.
kind of things.
Yeah.
Yeah, please follow it. Okay? Okay. And then, yeah, so definitely please, and then, execute, the code, and then let us know if you have any problem. And then, yeah, we will meet in the next week. And then, yeah, maybe we can form a team next week. Should be. All right? Okay.
Yeah.
Any
And I
questions so
think,
far?
we should next week we should check every single person, make sure
Yeah.
that they have executed the code.
Yeah.
Good
Because
luck.
otherwise, there's no, reason, you're taking this class. Yeah. All right. Any questions?
So when are we gonna work on the model for the potholes?
So I already gave, do you receive the email, right?
Yeah.
Now and then you can start it if you want.
Oh, okay.
So there is a, tutorial, new tutorial about, pothole, and then there is a data set, link for the data set. Yeah, please check it. Now and then, because you, pass, this, the simple code, then now you can try, the tutorial, which can be used, for the pothole detection immediately. Okay, that is,
Okay.
the homework.
Thank you.
Okay,
I have a question.
sure.
So basically, what we need to do is just test the model, like play with the different parameter, and then once we got it to the like the best model, we would just kind of replace the file that the model will access to the data set that you sent through our Gmail, right? And
So, yeah, but we're gonna provide, the submission method. All right. So we plan to, yeah, Juyong, and then, the final model, the best but PT, and then you can just save that as a kind of, the Jupyter file, right?
Yeah, Jupyter file, and maybe we need the PT file. This
You can just submit the PT file.
PT file. Yeah.
Yep. Simply, and then we can provide some kind of naming convention for the PT file for different teams. All right. Then you can just, rename your best.pt
Yeah.
and then just submit it. Did I answer your question?
Yeah, but also like I'm also asking about like the data where we would just change like where because they did the data set right now for this model is cats and dog, but later we just like replace that data set with
No. So if you did you receive my email about hackathon?
yeah.
Yeah, it has some paths for the data set, pothole data set.
Mm-hmm.
Yeah.
Yeah, so you just need to switch the directory from the cats and dogs to the pothole directory. And then
Okay, yeah, that was what I was just asking. Okay.
Yeah.
yeah.
So in any kind of, the machine learning or any kind of program, the basic modification, yeah, you need to provide the correct path to the input data. And you need to provide the correct path to your own output, the file. All right? At least, well, that is a kind of the must thing you have to do. All right? Okay, sounds good. Okay. Any other questions? Some other questions? But again, once you know this basic, the flow, yep, you can develop any kind of detection model because, all you need is a different data set. All right? That's it. And then this has lots of, practical kind of use and then use cases and then very practical applications. Remember that, AI, need to understand some visual information. Yep, this is the way. Okay? We can detect things from the real world images. All right, I just want to stop here today. And then Juyong, thank you. And then thank you for, joining and then provide some kind of, the good description. It's very helpful. And the others, and then, please watch maybe recorded video one more time. And then, well, just follow it and then just try it. Some part you don't understand, that is fine. All right? You can always ask some questions. All right, thank you so much. And then, see you next week.
Thank
Okay.
you.
Bye.
Thank you.
Thank you.